All right, hi everyone. How are you? So let's pull out those packets I gave you in class and pick up where we left off. If you look at Alia's picture here, well, oh, Alia, you got some glare going on there. Alia's picture, there is, I'm going to rewrite it over here, okay? So this is what we did in class. Remember, we factored the 4 out, okay? We wrote down the period, wrote down the vertical shift, wrote down the amplitude. And then Liz said, Ms. Yam, why did you write the axis of the wave at -2 when we're supposed to be going up 2? And I said, very good point, Liz. I messed up. So let's go over here. I just rewrote the problem over here, okay? All right. So here's my equation. We are in degrees, and I think I told you in class that, this is an error on Kudo's part. If this is in degrees, you should have degrees in your equation here. But be that as it may, okay, vertical shift up 2, here is my axis of the wave. Now, you might remember how we dealt with the amplitude. The amplitude tells us how high and how low below the axis of the wave you're going to go. So oftentimes, what I had you do, if I remember correctly, is I had you kind of mark those places on the y-axis just for your own reference, okay? Now, we figured out the period, which was 90 degrees, by taking 360 divided by 4. And now here's a recall for you. Remember what we did? And remember in class, I told you to scratch out the units on the x-axis because that does not help you at all. It makes for a very squished or just inaccurate graphing. So if you know the period's 90 degrees, everyone, remember what we did? Here's what we did. We went to the axis of the wave, we marked 90 degrees, and then what did we do, everyone? Yes, we cut it in half, and then we cut it in half again. Half of 45 is 22.5 degrees, okay? And then we have to figure out this part, right? 22.5, 45, and then this is going to be 45 plus 22.5 is going to be 67.5 degrees, okay? And what we do with our preliminary graph is we take care of the vertical shift, the amplitude, and the period. This, our horizontal shift, we do last. Preliminary graph first. Cosine. How does cosine start, everyone? Cosine starts high. So we've got high, middle, low, middle, high. And I'm going to just dot this. Okay, this is not my final picture. And the beautiful thing about review week is, if you really do it right, it makes life much, much easier if you're staying with me, okay? All right, now we're going to take care of this horizontal shift. We have to move left 11.25 degrees. Now, what's nice is 11.25 is exactly right here. It's half of 22.5. We have to move left. So what I'm going to do, just to keep things really orderly and clear, I'm going to extend my axis of the wave here. I'm going to make note to myself this here, that point right there. This is at negative 11.25 degrees, right? So now I'm going to shift everything left 11.25. And this takes a little bit of just being careful and taking great care. 45 degrees comes left, okay? This comes left right here. This comes left, right? Everyone okay? And here is my final picture. Yikes. Somehow, I think, you know what the problem was? I think I went too low with my blue here. Just fix that. Because I was wondering why. Okay, so here's my final graph. Everything shifted left, 11.25 degrees. Now, you'll remember from tests, sometimes, oops, I think I should, what happened here? Okay, well, again, what I always like to have is I like to have your axis of the wave marked at these values. So this is the value, right? This high point occurs at negative 11.25 degrees, all right? This point right here occurs at 11.25 degrees. This point right here, everyone, if the low point was at 45, I have to go back 11.25 degrees. This is going to be 33.75 degrees, right? Okay. This point here is going to be 56 0.25 degrees. What if I asked you for 2 periods? Okay, for 2 periods, you're going to want to be very careful. So I'm going to go over here and make sure that my demarcations are correct here. It helps when I color code, I'll be honest with you. Okay, because I asked for 2 periods, 2 full cycles. It doesn't say it to go in any particular direction. So I'm going to do this. So this is 90. That makes this, let's see, 90. You know what? I'm going to go backwards too. So this here is going to be at negative 22.5 degrees. And that is going to be where I have a low point. It's just easier to go back this way, okay? Then here, I'm going to have, let's see, negative 22.5, negative 33.75. Is that right? Negative 33.75 degrees. I'm at a low. So I'm here, right? All right, now let's move in the positive direction. So this here, let's see, this value I didn't find yet. That value that corresponds to this high point is 67.5 plus 11.25. So that's going to be 78.75 degrees. Okay. Then we're going to add another 22.5. I don't think I messed up. Did I, everyone? You can see this better than I can. You know what? I'm just going to go backwards. Forget that. I can't because I'm getting so, all my numbers here, I'm just making a big old mess. But, okay, so the next demarcation here is going to be, wait a minute. Hang on. Okay, I fixed it. It was right here. So this is at theta equals negative 11.25 degrees, and then it hits a low at 33.75. That's where I messed up. Okay, because the distance between a high and a middle should be 22.5 degrees, right? But the shift is 11.25. So basically, it's added incorrectly. Oh dear. Okay, I'm going to go negative here. So I'm going to add another 22.5, and we're going to have a low point at that point, okay? But I think you get my point here. You get what I'm doing, right? So this value of x is going to be whatever negative 33.75 minus 22.5 is, all right? That's graphing sinusoidal functions. Let's do one in radians. Let's do it. You want to do it on your own here and then play me for the answers? Okay, go right ahead. I'm going to start with the answers now. Go ahead, try on your own, and then replay me for the answers. All right, so the first thing I'm going to notice here is I've got to factor out a 2 from the argument of the sign. So 4 sine of 2 times the quantity, be careful, x minus pi over 2, right? Minus 1. Making a note to myself, I don't see any degree symbols. This is in radians. Be careful of that. It's not in radians because you see pi over 2, because there is something called pi over 2 degrees, right? It's in radians because there's no degree symbol. All right, so then I'm going to make a list of my transformations. I'm going down 1. My amplitude is 4. And my period is going to be 2 pi divided by 2, which is just pi. Okay? So I'm going to come down here and make my axes. And I'm going to label the critical values. Down 1, all that tells me is that negative 1 here is my axis of the wave, and the amplitude is 4, so I'm going to go as high as 3 and as low as negative 5. All right. Period is pi. That means I'm going to take my axis of the wave. I'm going to draw pi here, and then I'm going to cut it in half. Cut it in half again. 1 pi over 4, 2 pi over 4, 3 pi over 4. Preliminary graph, sine, 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 sine. Sine starts, middle, high, middle, low, middle, dot it. Okay, now I'm going to take care of this guy right here. That's telling me to move everything right pi over 2. Okay, so here comes my final graph here. We have everything right pi over 2. Let's go for some rainbow. Right pi over 2, that means this point comes here. This point goes here, right? This point comes here. I'm going to have to add some more. The axis of the wave. 5 pi over 4, 6 pi over 4, which is the same thing as 3 pi over 2, 7 pi over 4, right? 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, or just 2 pi. So I'm just finishing up, putting my graph down. Doink, 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 doink. Here I am. Maybe the question asks us for 2 transformations, or 2 cycles rather. Very easy. I'm just going to head backwards then at this point. Okay, there we go. There are also questions, everyone. Let's just might as well do it while we're here. There were questions where you were given a graph, remember that? Given a graph and asked to find the equation of that graph. So here's what I'd like you to do. I'd like you to generate an equation of this function right here. I'd like you to generate an equation of this function in terms of cosine. Now, everyone, how many different answers could there be? There could be infinite, depending on where you choose to start. I'd like you to do the equation of this curve right here in terms of cosine. Play me for the answers. Okay, many ways you can go about this, right? And you know that when you're looking at a sinusoidal or a cosinusoidal function, to describe it in terms of the other function, the only thing that changes is the horizontal shift. So you already know that this equation, which is the final one in yellow over here, 4 cosine of 2x, okay, minus 1. The only thing that changes when you take a sine function, right? This is originally a sine function right here, and you want to express as a cosine function, the only thing that will change is the horizontal shift. Now, maybe I am someone who wants to tell myself to start here, right? Because cosine starts high. Well, then I'm going to say x minus 3 pi over 4. Maybe you're a little wild. I don't know, who's a little wild in our class? Talia. Talia can be a little bit wild sometimes. I know you don't know that, but she can be. She can be a little wild. Maybe you're Talia, and she says, no, I want to start my cosine function right here. I want to start it down here, right down here. In which case, Miss Yam, if I start my cosine function down low, what would I have to change? Well, a couple things. If your cosine normally starts up high, and you want to start down low, what do you need? You need a reflection right there. You need a reflection, and then the right shift is minus pi over 4, okay? So those are all the things that you can do secondarily after reviewing graphing cosine and sine functions. And with that, I bid you all a wonderful good night.